graph a log function here. We're just doing a freehand sketch, just an approximate sketch to try to understand the features of the graph. So we're not getting super technical here. But let's say we're graphing something like y equals log base 4 of x minus 2, and then that plus 3. Okay, the first thing to know here is that this log base of 4 is not going to make a huge difference if you're graphing it by hand. The log base, the smaller it is, the taller it gets, but it's just not a big difference. Not enough to really worry about if we're doing a quick sketch. Now, if you're doing a more precise sketch, you need to build a table. Of course, you could always use a graphing utility as far as that goes. But we're just going to do a quick sketch here, just trying to understand what it looks like. So we're going to ignore that 4, long story short. Generally, anything on the inside of a parenthesis represents a horizontal shift, and we change the sign. So I'm going to change that to x equals 2 instead of negative 2. So I'm going to be right here. I'm going to make a vertical asymptote here. So I'm going to make a dashed line. This is not part of the graph, but it helps us draw the graph. So change the sign here. My next step is going to be to go 1 to the right. So from 2 to 3. And the reason we do that is if I make x a 3 right here, you're making the value of the parenthesis 1. And if you ever have a 1 in this position with a log, the value of the log is always 0. 4 raised to what power makes 1? Well, 4 to the 0 power makes 1. Long story short, if you go 1 above the asymptote, you're forcing this to be 0, and this becomes the y coordinate. So you would go over 1 to the right, always 1 to the right from your asymptote, and go up 3 here. Okay. Now you won't ever be on the left-hand side unless you have a negative in this position, which we're not going to do for this video. The way the graph looks, it's going to, anytime you have an asymptote, generally much of the graph is very close to the asymptote. So it's very, very close. And when you see the point, it begins to bend towards that point. And it's always an increasing function, but it's not very steep. And remember, we're just doing the intent of this is just to get an idea of the basic features of the graph. We're not trying to be very precise. That's the reason we more or less ignored the 4. Now the domain and range is worth mentioning here. Remember, domain is all possible x values. So domain, the x goes to 2 for my leftmost value. How far left, how far right is a way of saying domain. It goes left until we get 2. Now, it doesn't actually touch 2. The asymptote cannot be touched here. The function actually doesn't exist at the asymptote. So we put a parenthesis here at 2 to indicate that 2 is a boundary but cannot be touched. It goes right forever. Okay. Now your range is going to go down forever, up forever. So that's negative infinity to infinity. And as a matter of fact, every log graph will have a range of all real numbers, which is a very common range. So we'll look at one more of these. Again, very simple, keeping it simple here. I'm going to change the log base, though. Again, it doesn't, for a freehand sketch, it doesn't make much difference. So I'm going to ignore the 9. Remember, we're going to change this to negative 4. So 1, 2, 3, 4. Get a vertical line right here. From your vertical line, you're going to always go 1 to the right. That forces this to be a 1 in here. 1 to the right would be negative 3. Negative 3 plus 4 is 1. And the log of with 1 in this position is always 0. You would go up or down this number, but there is no number there. So I'll just leave it on the x-axis. And by the way, I don't think I said it in the last example, but you would not change the sign out here. Only on the inside would you change the sign. So as before, I'm going to make it very close to the asymptote, then bend it. You want to be careful here not to get perfectly flat, nor to certainly don't want to come back down. This is an increasing function. Your domain, D for domain, how far left? What goes left until you hit the value negative 4? but it doesn't touch -4. So it's -4 and then forever to the right. Your range value, it goes down forever, it goes up forever. So negative infinity to positive infinity. Okay, so just a couple quick sketches on logarithms.